Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will start Physics SSC 1. Now, new syllabus Physics SSC 1, unit number 4, turning effect of force, and today we will solve the numerical problem exercise 4 numerical problem question number 4.1 to 4.5. In this chapter, total numerical 4.1 to 4.10. In this video, we solve the first 5 numerical and remaining 5 in other video. Now we will start the first numerical. In first numerical, the given statement is find the resultant force of the following forces. Here some forces are given. We can find the resultant force of the following. In first part, A part, 10 Newton along the x-axis, and in B part, 6 Newton along the y-axis, and in C part, 4 Newton along the negative x-axis. Here two forces are given along x-axis, one is positive and other is negative. Now we can solve this. We can write the given data. F1x positive axis 10 Newton toward the x-axis, and F2x is equal to 4 Newton along the negative x-axis. First of all, we can find the force along the x-axis. We can add the forces of F1x plus x2x. Then Fx is equal to 10 Newton minus 4 Newton. The final answer along the x-axis is 6 Newton. Now we can write the force along the y-axis. Fy is equal to 6 Newton toward the y-axis. Now to find resultant force and the angle between them, theta. Now we can using the formula Fx is equal to Fx square plus Fy square whole square root, and for the direction theta is equal to tan inverse into f of y upon f of x. So we can write the solution. F is equal to fx square plus fy square whole square root. Putting the values, then we can write that f is equal to 6 square plus 6 square whole square root. 6 square is 36 and 6 square is also 36. Then f is equal to 36 plus 36 whole square root. 36 plus 36 is 72. Now taking the square root of 72, then the resultant force F is equal to 8.5 Newton. Now we can find the direction, then we use theta. Theta is equal to tan inverse into f of y upon f of x. Putting the value of f of y upon f of x, then taking the tan inverse. Now we have theta is equal to tan inverse 6 upon 6. 6 divided by 6, both are cancel out. The final answer of theta is equal to tan inverse into 1. Taking the tan inverse of the value of 1. Now the tan inverse of 1 is equal to 45 degree. So the direction force theta is equal to 45 degree. Now we have the resultant force is 8.5 and theta is 45 degree. In question number 2, find the perpendicular component of a force 50 Newton making an angle of 30 degree along x-axis. Here we can find the perpendicular component of forces. First of all, we know that what is a perpendicular forces. When a force acts on a body, they have produced the two axes along one x-axis and other second is y-axis. So these are called a perpendicular component. Now in this numerical we can find the perpendicular component f of x and f of y. Given force is F is equal to 50 Newton and angle 30 degree along the x-axis. Now we have write the given data. F is equal to 50 Newton and angle theta is equal to 30 degree. So we using the formula for x component, we have f of x is equal to question mark, and we using the y component, we have the component of force f of y is equal to question mark. Then formula of this component is f of x is equal to f cos theta and f of y is equal to f sin theta. Now putting the values, we have the solution. In solution, f of x is equal to f cos theta, then f of x is equal to value of f is 50 multiplied by cos 30 degree. Taking the cos 30 degree, its value is 0.866. 0.866 multiplied by 50, then x component force is 43.3 Newton. Now we can find the y component. Similarly, we can use f of y is equal to f sin theta. Putting the values in given relation, we have f of y, value of f is 50 multiplied by sin 30. Taking the value of sin 30 is 0.5. Now 50 multiplied by 0.5, then y component is equal to 50 Newton. Now the final resultant force f of y is 25 Newton and f of x is 43.3 Newton. In question number 3, find the magnitude and direction of force if its x component is 12 Newton and y component is 5 Newton. Now, in given data, x component of force f of x is equal to 12 Newton and y component of force f of y is equal to 5 Newton. We can find the magnitude of force and direction of force. So we write to find force F is equal to question mark and the direction of force theta is equal to question mark. Using the formula, F is equal to F of x square plus F of y square whole square root. And for the direction, theta is equal to tan inverse F of y upon F of x. First of all, we can find the first part, magnitude of force. In magnitude of force, part 1, F is equal to F of x square plus F of y square whole square root. Putting the values in given relation, f is equal to f of x is 12, so 12 square plus f of y is 5, 5 square whole square root. 12 square is 144 and 5 square is 25 whole square root. Adding the both value, 144 plus 25 is equal to 169. Taking the square root of 169, then magnitude of force F is equal to 13 Newton. Now in part 2 we can find the direction theta. Theta is equal to tan inverse f of y upon f of x. Putting the values, then we have theta is equal to tan inverse 5 upon 12. F of y is 5 and f of x is 12. 5 divided by 12 is equal to 0.4167. Taking the tan inverse of 0.4167, the final answer theta is equal to 22.6 degree along x-axis. Now the resultant, the magnitude of force is 13 Newton and theta is 22.6 degree. In question number 4, a force F is 100 Newton is applied perpendicular on the spanner at a distance of 10 centimeter from a nut. Find the torque produced by the force. Now, given force and distance are also given, we can find the torque. So, first of all, write the given data. Given data, force F is equal to 100 Newton and moment arm given that spanner perpendicular distance is called a moment arm. Moment arm is denoted by L. L is equal to 10 centimeter. Convert the centimeter into meter, then 10 divided by 100. 10 divided by 100 is equal to 0.1 meter. Now we can find the torque. So write to find is equal to torque, tau is equal to question mark. Then using the formula, tau is equal to F cross L. Finding the solution, tau is equal to F cross L. Putting the values, then tau is equal to F cross L is equal to 100 multiplied by 0.1. When multiplying 100 with 0.1, the final answer of torque is equal to 10 Newton meter. The resultant of this answer is result. The torque produced by the force is 10 Newton meter. In last question, question number 5, a force is acting on a body making an angle of 30 degree with horizontal axis and the horizontal component of force is 20 Newton. Find the force. First of all, understand the statement again and we can find the force. Given data is angle along the horizontal axis, x-axis is 30 degree and force horizontal component f of x is 20 degree. Now we can find the force. So write the given data, angle theta is equal to 30 degree and horizontal component of force f of x 20 Newton. To find the force F, first of all understand the formula how use and find the force. So using the formula F of x is equal to F cos theta. Cos theta is multiplied by here and divided on other side. Then F of x is equal to F cos theta. Putting the values we have 20 is equal to F cos 30 degree. Now we put the value 20 is equal to F cos 30 degree is equal to 0.866. 0.866 divided by other side, then we have F is equal to 20 divided by 0.866. Now 20 divided by 0.866 is equal to 23.1 Newton. So the result is a force acting on a body is 23 Newton. So in remaining numerical in other video, best of luck, take care.